Okay, so today I'm going to start with a new series that is basically today I'm going to talk about a GNU plot. GNU plot is a graph plotting tool. It is available in Windows as well as in Linux. Here I am using Linux environment or Linux operating system. It is the Linux Mint which I am using. And to install Gnuplot, you have to give a command sudo apt-get install Gnuplot. This is a command and it is already installed on my system. So now it's already installed. So let us start with this and series. I will start talking about the functions, that how functions looks like and what they talk to us. So this is just a beginning. So open the terminal, and in terminal you simply write down the command Gnuplot and right. So this will open in front of you. And what will you do? Suppose I want to plot a line. That line is known as y is equal to fx. I want to plot. Say I am interested to plot that y is equal to x, and it's always a straight line, right? It's always a straight line passing through a region. So I will start with this, right? So how this can be plotted using a GNU plot, let us have a look at that. So it's simply, if you write down plot x, then a graph will open in front of you. You will see this, right? Now you can see this is the graph which we are getting. Sorry, yeah, this is the curve which we are getting. So, and its range is from -10 to 10 along x-axis, and along y-axis its range is from -10 to +10. And there is another very interesting way to plot this, and for that we will write down a small script containing a small steps so that this graph looks very beautiful. So for that, what should I do? Let me write down that script. So I press Q on it, and so that I will come out of it, and just a minute. Yeah, what happened? Let me open it again. Yeah, now it's open. Yeah, it's ls. Now what I will do, I will make a .gnu file, right? Let us make a vi test, or I can use gedit test.gnu. It's a file which I am opening. This gedit window will open in front of us. So what I will do, suppose I want to set the range. Set x range I set x range from -8 to 8, let us imagine, and similarly I will set y range so this is a way that y range can be set again from -8 to 8. And suppose I want to save the graph. So for that, what I will do, I will give a command set terminal postscript, then with what name I want to save, so set output. So we will prefer to make a output file with the name, say test.ps, right? So I want to make a postscript file from this. So this is one thing, this is the terminal which I set, and then I will use this with what name I want to save it, and this is the X range and the Y range which I have chosen. And let me make it enlarge if I can do it. Okay, so that's what I did, and then this is the range which I set, and then let me give a command plot x, means the command which I am giving in the GNU plot, right? And then let me save it. So I saved this with the Control S command, or you can simply say save, right? So you can save from here also. So now what I will do, I will again go to the terminal. So what we will do, in the terminal, what I will do, I will give a command, because it's already there in this directory, which is a path of the directory, right? So it is already there. So what I did, I give a command Gnuplot, and .gnu file is already there, so I will give a command load test.gnu. It gives some error, so let me see that what is there in it. So test.gnu. So yeah, set X range, set Y range, set terminal, it's a postscript, set output test.ps, set X range is this, set Y range is this, and then plot X. I think everything seems to be good. Let me see that why it gives some error. Gnuplot, okay, you have to give it in the inverted commas, right? So this is the command which you have to use. Let me enlarge it. This is the command which you have to use, right? So if I give this command, right, then it will make a .ps file of it, right? So it has made, if I go to this, it already make a this graph. So that's what we are getting out of it. Let us have a look at it. So that's what we are getting. See, this is the graph. This is from -8 to 8, but its color is black. So if, let me go back again. So if I open test.gnu again, and then in case of postscript, I will write down also, you have to make changes in the test.gnu file. It is color enhanced and save it. Then you again go to the Gnuplot and give a command load test.gnu, and if you again try to look at the graph which you are getting, it is a colored graph which you are getting now, right? Then another thing which is needed, if we want to draw a line here, say x-axis and y-axis both are at the 0, if we want to plot that, then for that we will use a very interesting command. Say if I want to plot a line here, suppose I want to plot this line and I want to plot this line. So if for this, what I will do, I will make the following changes into the script. So let us go to the again that script. You have to make changes into this script here. After this you give a one command. That command is set x0 axis, set x0 axis, then set y0 axis, right? Then you will get that line. So let me save it again, and then again go to the Gnuplot, and then again load. When I loaded it, I will get this line, right? This is x-axis at 0 and y-axis also at 0, right? So both we have shown here using a very small command. Then again, if I want to level or give the title, then for that you have to give a command set title, and title is basically, say it is the y is equal to x, we want to plot it. This is the equation which we want to plot, and then along x-axis means I want to level x-axis and the y-axis, so set x level, and x level is labeled as say x, and say y level is also set y level as y, and then we save it. And then we save it and then go to the Gnuplot again, and then again load the same script. Then the script which you are getting this. Say y is equal to x is the title of the graph which we are getting, and it is the x, means we are plotting x here, so it is the y level and it is the x level. So this is a very small script which I am using. And now if we want to plot, because here I want to show you that how functions looks like. So for that, what we will do, so again I go back to the same script. Then if we want to plot multiple functions, say we want to plot a y is equal to suppose we are interested to plot or different functions at a time. We want to appreciate those functions. Say y is equal to x, y is equal to 2x is another function, y is equal to 2x plus 3 is another function, y is equal to 2x minus 3 is another function, y is equal to minus 2x is another function, and y is equal to minus 2x plus 3 is another function, and y is equal to minus 2x minus 3 is another function. If we try to look at these functions, then this 2, this 2, this 2, this minus 2, these are basically the slopes, right? And these values, these are known as Y-intercept. Means they are intersecting where the line is intersecting along on the y-axis. It is the Y-intercept, right? and slope is means the delta y over delta x. This distance is delta y and this distance is delta x. This is the slope, right? And slope will be 1 when x is equal to y, and means the angle is 45 degree. Angle is 45 degree. But when slope increases means it goes like this. So let us try to look at all these functions graphically using the GNU plot. So let us go back to again to the GNU plot. So if we want to plot multiple functions at a time, say it is 2 star x. 2 star x means it is a 2x. Then 2x plus 3 means 2 star x plus 3. Then comma 2 star x minus 3. So first of all, let us see all these functions. So if we try to plot these functions, let us save it and then again go to the GNU plot and then load the same script. So let us see what happens. Now see this graph. It's a very beautiful graph which we are getting. Right? Now see, let us understand it. So this is the x-axis. Now this is y is equal to x plot. Then let me go to this one. This is 2x. This is 2x plot, this one, and it's again passing through the origin. Its slope, the slope of y is equal to x will be this one, whereas its slope is this one, means its slope gets increased. But if we try to look at that y is equal to 2x, y is equal to 2x plus 3 and y is equal to 2x minus 3, then these all having the same slope. So all the lines are parallel, but because of their slope is same, but they are intersecting at different points. This line is intersecting, or this line is passing through the origin. See, this line is passing through the origin, but this line is intersecting this line. This line is intersecting by axis at this point. So this is the y-intercept for this. This is 3. It is the y-intercept. On the other hand, if we try to look at 2x minus 3, then it is intersecting at this point. This y-intercept is minus 3, which we are getting. Now let us go back to another graph. So for that means other functions, sorry, not graph but another functions. So let me go to the again same script. Let us make some changes to the same script. Say it is minus 2 star x comma minus 2 star x plus 3 minus 2 star x plus 3. That's what we are getting. Sorry, minus 3, right? So these are the 3 new functions which we are getting. And let us see how things will change. So this is the curve which we are getting. So now the slope gets changed. Slope will become negative. So these are the negative slopes which we are getting here now. So see, so let me see. So their slope is negative, but here the y-intercept is this one, is positive 3. So it is the y-intercept for this line also, for this curve, and whereas for this curve the y-intercept will remain the same. So if we compare this part with this part, then their y-intercept will remain the same, but slope gets negative with respect to each other, right? And similarly here the y-intercept will remain the same. So this is a very beautiful way that we are looking at the straight line, and the equation of straight line is equal to y is equal to mx plus c. So here today we try to understand this very simple equation of line, that is y is equal to mx plus c, with the help of a GNU plot. So that's all for today's video, and in the next video I will talk about different other type of functions. So that's all for this. So yeah, let me stop it now.